on page 49. First one there, we're given the two legs, the length, and we're trying to solve for the hypotenuse. So a squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. 25 equals c squared. Now what do we do next? Yes, Elizabeth, thank you. We have to take the square root. Square root of 25 is 5, and c squared, of course, is c. So c, the hypotenuse, is 5. Now, one way to check your work here, the hypotenuse is always going to be what in relationship to the other two legs? Anybody? CC. Yes, that's right. The hypotenuse is always going to be the longest of the three numbers that you have. The two legs, each of the two legs will be shorter than your hypotenuse. So if you come up with a number, c squared, c equals something, and that number is shorter than your legs, then you probably did something wrong. All right, let's look at model 2. The hypotenuse of a right triangle is 10. One leg is fine. 5, find the other leg. Okay, a squared plus b squared equals c squared. A squared plus 5 squared equals 10 squared. So a squared plus 25, 5 squared is 25, equals 10 squared, which is 100. So now what do? We solve it algebraically. We subtract 25 from both sides of the equation. We have a squared equals 75. A equals the square root of 75, which, as we broke down the square root before, that breaks down to 3 times the square root of 3 times the square root of 25. Square root of 25 is 5. So we have 5 times the square root of 3. We can't reduce the square root of 3 any further, right? Right. Okay. Next one, model 3. Is it a right triangle? You have your different measurements there. So you square them. 6 squared is 36. 8 squared is 64. 10 squared is 100. Add 36 and 64, and it is 100. 100 equals 100. So it is a right triangle. Next page, they give you an example of one that is not a right triangle when you add the numbers together, so we won't do that. All right, I'm going to ask you to do 2.90 through 2.105, but let me just show you for the first one, 2.90, because again, it's one of those ones that's so easy it can be hard. It's really not that difficult. What you're doing for that one is very simply it says to write the equation. That's all you have to do is write the equation. So you have x squared equals 4 squared plus 7 squared. That's it. You don't solve it. That's all you do. We're looking at the figure that's below 2.90. X squared plus 4 squared equals 7 squared. So I think you can do the other ones. I think you can do the next group of problems. It says the lengths of the sides of a triangle are given. Can the triangle be a right triangle? So you just plug into the Pythagorean theorem, solve it, and see if in fact that's true. Notice again that the longest of those three numbers is going to be what? What? What's the longest of three numbers? Jamie, thank you. The hypotenuse. The longest of the three will be your hypotenuse, or the letter C in your equation. Next group of problems, you're given a right triangle, or given a triangle, and it is a right triangle, excuse me, and you're given different measurements for the different lengths, okay, and you're supposed to figure out the missing number. You can do this first one in your head, okay, again, Pythagorean theorem, a squared plus b squared equals c squared. A is 5, b is 12, what is c? A squared is 25, b squared, 12 squared is 144. 25 plus 144 is what? 169. Correct. Take the square root of c squared is c, square root of 169, and what is that? Becca, thank you. 13. Yes. So that's how you solve that. So you solve for the missing parts. Okay, one more group of problems. 2.106 through 2.109. Do not do 2.110 on page 52. Now I want to show you the first one, 2.106. Okay, it says a man walks 7 miles due north, 6 miles due east, then 4 miles due north. how far is he from his starting point? I think the guy's kind of walking, I don't know if he's a little tipsy or what. He's walking a little crazy here. But anyway, let me show you on the board. All right, so we have this guy. He's walking north 7 miles. Then he's walking east 6 miles. And then walking north 4 miles again. Now, very simply, this can be put in, these numbers can be added. 7 and 4 is 11. So literally, even though he walked this 6 miles in between, he's literally walking 11 miles north and 6 miles east. Okay? So we can create our right triangle this way. This is a right triangle. So 11 and 6. So we have A and B. And now we have to do is solve for C, which I've labeled as x. So a squared plus b squared is going to equal c squared, or x squared, in this particular problem. And it's really very simple. Okay, so 8 squared, 11 squared is 121, and 6b squared is 36. So 157 equals x squared. So x equals the square root of 1, see if I can write these numbers right, 5, 7. Did that do it? Hey, I did it. How about that? Okay, the square root of 157. And that's the answer. We can't reduce it any further. All right? So I'd like you to try to do 2.107, 2.108, and 2.109. Notice in 2.107, that it's an isosceles triangle. So if it's an isosceles triangle, then the legs are what? Yes, they're the same length. And notice we have an equilateral triangle drawn with an altitude dividing it into two triangles. Okay, an equilateral triangle and altitude will create two triangles. We've done this before, and each side is 6 feet. So you have 6, 6, and if the altitude will divide this into 3 for each of the other two sides. And so, once again, we're solving for the missing parts. And likewise on 2.109, again, an isosceles triangle, which means that the two legs are the same length. Okay, the same length. So I'd like you to do those as well. And when you can, I don't know how much time is left in class, but with whatever time is left, you can go ahead and work on the problems there. We'll answer them on Wednesday. I won't see you on Monday because Monday's Martin Luther King Jr. holiday. Remember a great man in our history. And so I hope you have a great holiday that day. And we'll meet together again next Wednesday, which is what? Hump Day! Yes, it's Hump Day! So we're going to meet again on Hump Day! Thank you very much, Carol. Denver, thank you. Oh, don't mention it. It was great to be with you, Mr. Reinhardt. I enjoyed working with you. Yes, so did I. It was a lot of fun. So we'll see you. Have a great time until next time that we meet. So long. Well, goodbye, guys. Thank you again for your help. Appreciate it. Students, I'll see you next Wednesday. God bless.